Hello, everybody. This is the official start of the webinar. Welcome. Today, we're going to talk about modern Wi-Fi design, whatever that means. And we have quite a bunch of people lined up here for you as well. Before we get started, could somebody please try and use the questions board so that we see that it's actually working and all that. I see that Mario Gingras sent another message on the questions board saying, "You all look tired." I wonder why is that?
That is true.
Okay. Questions board test. Okay, thank you, everybody. It seems like the question board works. And at any time you want to ask anything, just shoot your message to the questions board and we will answer them. We actually, behind the scenes, we have Ilpo, the bear of Helsinki, answering the questions, as well as Tomi Tambo Bombo Järventie answering the questions as well. So we have some serious, high-flying mist expertise on board behind the scenes as well. Well, who else do we have on the line? Chris Reed. Who are you, man? And how are you?
I'm excellent, thanks. Thanks, Jussi. So I'm Chris Reed. I'm a principal consultant over at Verizon, part of the Intelligent Networking Pro Services Group. So I get to do designs, deployments, and assist with large public venue Wi-Fi, as well as enterprise K-12 higher ed, all sorts of stuff.
Thank you so much for joining, Chris. Much appreciate that. And if it's okay, let's have a kind of like a free-flowing panel type of a thing today. You okay with that, Chris?
That's what I expect anytime I chat with you.
Wait, are you just now planning the webinar, Jussi? It already started. You can't keep planning it now.
No, I have it fully scripted, Joel. Fully scripted. Oh. This is actually a part of it, right? You were reading that from the prompter, weren't you?
Yeah, my teleprompter's up. It's running. It's good. Did you not get yours, Joel?
So is my teleprompter.
Same here. Missed Wi-Fi is great. Anyway, next presenter. Thank you for joining, Nick Turner. How are you, man?
Doing very well, thank you. Yes, pretentious food connoisseur. Thank you for preparing the intro slide. I appreciate this. You can see I've teleported through time from this picture here when I was about 12 years old. You said you wanted pictures when we were really young, didn't you?
I did, and you sent none, so I took the liberty of preparing them myself.
Yes,
so you've been doing AP on a stick from a young age then, huh?
AP on a stick from a young age. I'm based in the UK, and I now work for a very small independent Wi-Fi consultancy called Badger Wi-Fi.
Very cool. Very cool. Thank you so much for joining, Nick. Look forward to it. And then there is this guy.
Hey, this is Joel. I like old Macintoshes, I guess, based on the photo here. But ask Joel about. I haven't seen this slide before. Alter Egos, Flat Joy, the Boise Balmer. Oh man, that was terrible.
You specifically prepared this slide, man.
Yeah,
don't lie.
Well, but yeah, my name is Joel. I'm from Boise, Idaho, which is kind of towards the Pacific Northwest side of the United States, and I am the channel sales engineer for Mist.
And you have done some. You have a career also with Wi-Fi design and troubleshooting. You have worked for MetaGeek as well as Ekahau back in the day, right?
Yep, correct. Yep.
So you good with talking Wi-Fi design today as well then?
Oh, yeah, I guess I could do that. I'll get ready really quick while you introduce the next people.
All right, thanks, man. I appreciate that. You have 2-3 minutes easily.
Yeah, no
Francois.
problem. I got it.
Hey, good morning, guys. Francois here. So I work as a Wi-Fi consultant out of Canada. I'm originally from France, and I'm happy to be here and also co-host the Clear to Send podcast with Rowell. I guess you guys will hear about Rowell. We do it every week, and we talk about Wi-Fi. So if you like podcasts and you like Wi-Fi, you should definitely check it out, Clear to Send.
Thank you. You guys have been so consistent and grown the audience so much. So congratulations on that. Thank you for joining, Francois.
Thank you. No problem.
Then we have Mr. Second part of Clear to Send, or should I say first part or half part? Which one are you? Rowell, how are you, man?
The other half. Thanks for having me, UC. Glad to be up early for this thing. My name is Rowell. I co-host the Clear to Send podcast, cleartosend.net with Francois. I work as a network engineer in a university and try to do as much Wi-Fi as I can.
Very cool. So you have your hands in a lot of stuff, right? The university Wi-Fi, then various different projects and all of that. So you've seen a lot of different environments.
Yeah. Is that a different way of saying I work too much?
Maybe. All right. And yeah, I am Jussi. Nick Turner, you want to introduce me?
And last but not least, introducing Mr. Jussi Kiven whatever.
You,
and the that's Joel. That's your joke. But anyway, yeah. Primary topics of interest with Jussi would be Die Hard and and Nicolas Cage pillowcase. I haven't seen many of those recently, though. Is there a place where we can purchase those?
I think if you Amazon Nicolas Cage pillowcases, you will. Yeah. I mean,
UC has an Amazon store.
Read the
shipped directly
reviews
from Finland.
as well. We don't get Amazon here, so I have to actually ship them to US, go get them. I call them conference trips, but it's really for retrieving my pillowcase. Thank you, Studier, for allowing me to expense all the pillowcases on company dime. Studier is my boss. Anyway, so we have a couple. You guys do a lot of podcasts. So Hidden Node, a couple of words about your guys' podcast, Joel and Nick. If you have to describe Hidden Node in 30 seconds.
Yeah, if Rowell and Francois' podcast is like the epitome of useful Wi-Fi information, Nick and I's is not.
We're like the mirror image of that.
Yeah. Just take Rowell and Francois' podcast. Ours is the complete opposite of that. In fact, the name is even misleading because it's not even really a Wi-Fi podcast. We get into Wi-Fi a little bit sometimes, but it's really just whatever Nick and I feel like talking about at the time. So.
Old men rant at clouds.
That's exactly right.
What about Clear to Send? How would you describe it?
So we're the opposite of Joel and Nick. Well, we actually we release episodes every week about Wi-Fi over at cleartosend.net. So we try to pick topics that are relatable to a lot of people if they're trying to either learn how like 11ax works, or if they've got something specific where maybe you wanted to learn how fast roaming works. We try to tackle a lot of different subjects with Wi-Fi.
Very cool.
Want to add anything, Francois?
No, we also do some interviews. So sometimes we have people on to talk. Lately, we had people talking about 6 gigahertz. We also interviewed the CEO of the Wireless Broadband Alliance. So we have some nice interview as well as covering technical subject like Rowell mentioned.
Very good. So is this okay for an agenda? Joel, you did prepare like a 100-second Wi-Fi design fundamentals.
Oh, I thought it was 200 seconds. All right.
Oh, did I promise you 200 seconds?
No, let's do it in 100 seconds. We'll just do it twice as fast. No problem. I got this.
Okay. Yeah.
I'm going to say 120
right.
seconds to make it easy to set the timer.
Okay. Hold on. I'm starting my stop. You have slides, Joel?
Yeah, I have slides. Yeah.
Oh,
I actually have slides.
Then I'm gonna switch it over to you.
Oh, okay.
You ready for 100 seconds of Wi-Fi design fundamentals?
No,
Let me know when you want to start, and I will start my timer.
Okay, all right. So that's not the right screen. Don't look at that. That's like the information. Oh man, I messed it all up. I can't figure out how to reshare my screen. How do you Pick the different screen. So in GoToMeetings,
You're at 40 seconds, man. I'm kidding.
Okay, now it's sharing both screens. All right.
This is the worst webinar I've ever seen.
This is the worst webinar. We're going to get feedback that says worst webinar I've ever attended. But time for 100 seconds of information. Are you guys ready? Because we're going to talk about how to do Wi-Fi design in 200 seconds. And I totally practiced this, I promise. So the first thing that you need to know about designing Wi-Fi is that, I need to start my timer, is that Wi-Fi is half duplex, which means that on any given channel at any given time, only one device can speak at a time. So for example, if you have an access point that's transmitting to another client, everything else on the channel has to shut up and be quiet. One thing talks on a channel at a time, which means that we at Mist are pulling a fast one on you. We're not selling you switch-like APs. We're selling you Ethernet hubs. That's what these things are, Ethernet hubs. And so we have to break up our contention domains to make sure that everything is able to talk. So in the 2.4 gigahertz channel, we have 3 channels to work with. We have channels 1, 6, and 11. In Europe, it's a little bit different, but we're going to stick with this for the purpose of keeping this in under 100 seconds. And because we only have 3 channels, that means we have 3 contention domains to work with. So what we do is we split up all of our access points on different channels to make sure that they don't have to take turns talking. For example, the 2 APs on channel 1, we try to keep them away from each other so that they don't have to take turns talking with each other, and all their clients don't have to take turns talking with each other as well. Now in the 5 gigahertz band, it gets a little bit easier. Again, I'm using the American example here, so I apologize for that. But here in the US, we have 25 channels to work with in the 5 gigahertz band. So that way, that means that we have 25 different contention domains to work with. So doing channel planning is a lot easier, but it's still not perfect. You get into a crowded environment and you can still have access points that can hear each other and thus have to take turns. So this can be really, really bad. Now, one thing that a lot of people do is they use wider channels, but when we start to use wider channels, then we have less of them to work with. For example, if we use 80 megahertz channels, then we only have 6 of those to work with. That's only 6 contentions to work with, and so that won't work at all. We need to use narrower channels like 40 megahertz channels and 20 megahertz channels to make this all work properly. Now, signal strength, we have to provide good signal strength. I'm just going to throw a dart at the dartboard here and say that negative 67 dBm is a good signal strength for streaming video. Negative 30 dBm is a really high signal strength, and negative 90 dBm is a very low signal strength. You see, how am I doing? I'm out of time already? I'm already out of time.
No, go man, go man. We just increased you to 200.
Oh, wow, I got 200 seconds now. Okay, cool. So another thing that we need to provide for our client devices is good signal. We need to get good signal above the background noise. If you've been in a noisy room before where you've had to yell at other people to help them understand what you're trying to say, that was an environment where your voice had a low signal to noise ratio. We want to provide high signal above the background noise so that clients can hear each other and speak more efficiently. And when the signal to noise ratio is good, we get to go to faster data rates, which is this way. We want to help our clients go this way as much as possible, but when there's a lot of noise, when signal strength is bad, clients have to slow down. They have to go this way and use slower data rates, which consumes more airtime, causes everything to talk slower, and nothing works as well at all. So when you design network, there's several things you have to do. You have to gather requirements from your customers. You have to measure walls, scale a map, see where the ceilings are. You have to perform your design. You have to deploy the network, and then you have to perform a post-install validation survey where you actually go and survey the network, make sure that the network met the requirements that you were setting for it. And you can do that either with a continuous survey or a stop and go survey, but don't do stop and go surveys. Those are slow and those are dumb. You really want to use a continuous survey. And not 200 seconds, nice. But 250 seconds? How long did it take? I don't even know.
No, yeah, something like that. So you're still very, very good. Thank you so much, Joe.
Sure. Right. Yeah, and to everybody that just listened to that, now you don't have to take the ECSE design from Keith and Rowell. So
yeah, let alone those CWMP courses or
yeah,
whatever.
You don't need any of that. So.
Yeah, you can just look at that, and if you need a refresher, then see that again, and you can call yourself a Wi-Fi Jedi, Wi-Fi Master. Whatever certificates you want, we can print them.
Yeah, I think we'll give you a free certification for that, right? We'll send you a plaque and everything just for listening to that. So good job.
Yeah, we will, like a plaque made out of real platinum and gold and all of that. So anyway, I may have overpromised again because it's what we do. what were we supposed to talk about next? Maybe if we had to choose like a few of the like most fundamental things about Wi-Fi design, like let's say everybody needs to explain like a fundamental thing about Wi-Fi design in under 2 minutes. We'll start with Chris. Chris, take the ball and present your Wi-Fi fundamental.
Fantastic. I don't even have any slides, Joel. So I think I'm going to come out on top on the timing. So my topic that I wanted to present was really the fundamental concept of garbage in, garbage out. That your predictive design is the result of multiple inputs, and like any process, the quality of the output is going to be directly related to the quality of the input. A chef isn't going to make a great meal with garbage ingredients. A bartender isn't going to make a good cocktail with plastic bottled Fleshman's gin. That coffee isn't going to be delicious by starting off with very old beans. There's a lot that you can't control in wireless, so you try to be as accurate as you can and control the things that you can. Your ingredients are going to be the data that you feed into that design. So starting off, you really need to have a fundamental understanding of all of your clients, the devices, their difference in signal strength, that there's a lot of variation even within the same device type. So if you have an iPhone 8, that you can be a 6-7 dB swing between those devices. So make sure that you understand the devices that are in your space and that you're going to be designing for. You also want to have a true understanding of the coverage spaces when you walk in. Floor plans get out of date, maybe marked up as a storage room, but you walk in and realize that it was converted to a small learning space or a small office or something like that, that you need to go on site in order to validate the floor plans and validate the wall types. You need to measure the wall attenuation. That's the only way that you're going to get an accurate predictive design on the backside, is that going on site, measuring the wall attenuation with the signal generator, and I'll show you how to do that a little bit later. But that if those wall types are off and you just pick the default values, you're going to get you're going to get a poor output. It might be okay, it might work fine, but wireless is very resilient and very robust. So you want to make it as good as it can be. Like Joel said, you want to get down and to the right, get those high data rates. And the only way you do that is by making an accurate design. And back to you.
What is the worst thing one can do where it manifests as in, garbage out?
So I think just making assumptions that you actually can have the opportunity to validate is that if you just take a floor plan and assume that everything is drywall and you go on site and that it's concrete walls, you're not going to have enough APs in the space, or you're not going to be covering the spaces that you need to be covering. That if you put an AP in an adjacent office and you've got a concrete wall and you've got a concrete wall that signal has to go through, that you're just not going to have the signal that you need in the adjacent office, and you're going to have a poor user experience.
Yeah, if I can add to that, I would say the floor plan is also very important. You can, if you take a picture of a floor plan with a weird angle, and the floor plan has a whole bunch of different colors, then that's going to be garbage inside your design as well, I would say. Yeah. So it starts with a floor plan, a good floor plan, right?
Yep.
Absolutely. Like how many times have we run into problems trying to overlay heat maps on a red background floor plan? What did you say, Nick? What was your slide about?
Well, it was an example of a good floor plan. Like this is what we're looking for. When you've got to make sure you've got a scale on your floor plan, and you can see where the doors are. This is a window. I mean, yeah, just make sure you're starting off with quality ingredient. Yeah,
that's on lined paper, Nick, so it's scaled.
Yeah, I was gonna say, like a hand-drawn one on lined paper. Is that the example of a good floor plan?
I think you take a picture with one of those. Didn't you use one of those AR things for making that plan, Nick? Right?
Yes.
Was it direct?
Yes.
Yeah. The AR.
I used my AR pencil for that.
Anyway, Rowell, what's your favorite, like, super important aspect of Wi-Fi design? Do you want to share a screen?
I don't have anything to share right now, so I'll just take
Dude, how did
after
you guys
Chris.
prepare for this webinar?
So I'll just talk about it.
All right.
Mine is about actually talking to the end user and seeing how they're going to use Wi-Fi, because a lot of times we focus on the infrastructure side of things and designing for minimum, your least capable client. Sometimes we forget that, hey, how is this user going to be using applications, and how are they going to be walking around in the office or whichever environment, because you tend to find out how what the expectations are from these people. And when you get these expectations, you start to discover things that you didn't consider in your design. Like maybe they're saying, hey, I'm going to be using this high throughput application over Wi-Fi, which you maybe thought was going to be over a wired network, but they're like, no, I can't because there's no drops over there. So I'm going to image 100 plus laptops over wireless over here in this corner. And when you don't have that type of information, then you can't set the right expectations. And when you're just designing based off of, say, how many butts are in the seats and going times that by 2, that's how many devices we're going to have, and everyone's got a Apple device, then we might be designing for the wrong applications, the wrong capacity. And so I like to talk to the users and even have them show me what they're doing with their devices, so I can further design for their needs. And I have run into some situations like that on a campus where in one corner of a building we had a teacher who was saying, yeah, I have about 10 students on laptops over wireless, and they're using GIS applications, which is like a lot of I don't know how to describe it. It has to do with like Earth, and they load an application. All I know is they loaded an application, multiple tabs and windows that all generated a lot of traffic over wireless, so it was very slow. And I had to do it designed for capacity, and that ended up being more APs and antennas than I had originally designed for that corner of the building. So when you talk to users, you finally understand, hey, okay, I see how you're trying to use Wi-Fi. Maybe I'll figure out what else I need to incorporate.
Absolutely. Thank you, Rowell. Who's next? Francois.
Yeah, so I guess I wanted to talk about a specific topic, and I guess it's kind of the same thing as what Chris and Rowell said. I wanted to talk about the important fact of communicating with the customer, right? So the first step of a Wi-Fi design is usually gathering the requirements, and sometimes that step is overlooked, right? You just ask a couple of questions and then you start your design. But I think it's very important to ask the right questions and the proper questions if you want to understand, what the customer wants and needs. So going back to Rowell's point, understand how they're going to use the devices and applications. And then going back to Chris' points, it's important to have important quality data to start your design and start your design work. And also it's important to communicate to the customer so you can set the expectations, right? If they have an unreal view of what the Wi-Fi will be, you can right away at the beginning of the project explain what will be possible, what won't be possible, and how you'll be able to work together to make important things work correctly, right? So it's actually important to ask the proper questions. One example of the questions we ask at the beginning of a project is we ask, Mr. Customer, which area do you want to cover? And usually the answer we get is everywhere. I want to cover everywhere, right? So when the customer asks me that, I usually ask other questions to refine what everywhere means, right? So I was like, when you say everywhere, you mean everywhere? And then if they're still like, oh yeah, I want it everywhere, this is my new Wi-Fi network, next generation, everything wireless, then I start to refine it, and I usually start with the outdoor spaces so they can get the idea. So I'm like, what about the outdoor spaces? You want to cover the parking lots? And they're like, oh, maybe not, maybe I don't want to go out there. And then you start refining, do you want to cover the bathroom, the electrical room, the mechanical room, and so on. And then they start getting the idea. And then in some environments, you can even get more specific because the area you will cover will change your design. So I've worked in an environment where they needed coverage in like big freezers. that will impact the design. So you have to ask those questions, set the expectation. We're going to need different equipment for these areas, and so on. I've worked in environments where they had, big painting rooms in warehouses. Once again, that's hazardous environment, so different equipment. So you can ask those questions so the customer understand your work a little bit better. They can understand, what to expect from the network, and then you can get into all this conversation about expectations, right? What type of application do you want to do? How many users? Going back to Rowell's point, even if you think you're going to have, 60, 100 users with 3 devices each, they're not all going to be used at the same time. You can talk about that. If you want to talk about, the applications, and they're like, okay, we have all these different devices and we want to support location and voice. Can you make it work? Then you can talk about, how everything works, and maybe we might not be able to design for every devices for every application. Let's try to focus on what's important, and I'll let Joel talk about that, I guess, at the end. But I think communicating with the customer at the very beginning of the project is important, and I think I'm over time. I'll get back to you.
That's the thing. Like, first of all, if customer says everywhere, that has a pretty significant price tag put into it. Like everywhere coverage is super expensive. The other thing I really like that you said is the dilemma of like, what is capacity for the customer? So if you have 100 people, what is the probability that every single person will at the same time download, unpackaged 4K video? Sure, it can happen to 1 or 2 of those users every now and then, but often capacity calculations are made on the absolute worst case scenario, like every single user doing the worst thing that they can, and that doesn't happen very often. Anyway,
go ahead. I was going to say, in order to prove that point, for us, it's easy as engineers. We can just ask the customer to look at their, the network usage on the switchboard that the AP is connected to. And if the customer doesn't have a lot of users, we can just use, other customers' data and show them that this is, Wi-Fi design I set up for, let's say, university, and they had 100 students in the room, and here was the network usage of my AP, and then you can showcase that or prove the point pretty fast.
Yeah, absolutely. Nicholas Turner.
Yes, my topic. My topic has already been touched upon ever so slightly, but I wanted to hark on about floor plans being very important. But maybe seeing as we're in the business of pilfering other people's topics, maybe I'd like to just jump in and say that I think expectation management. In fact, this is true for Wi-Fi design, but also life in general. I think expectation management, like, that's possibly one of the biggest things we could take away and try to promote. So. Yeah, being upfront with the customer and being like, this is what you want. Great, we've detailed it. Now let's talk about what is realistic. But then on the topic of floor plans, and this is the expectation management again. If the customer is unable to provide me with quality floor plans X many weeks ahead of me visiting the site for the first time, I need to start setting expectations now that, okay, you can't provide me with good quality plans. Can I create a wireless design for you without plans? No, I can't. And then if you cannot, and so please try and find me some plans. If you cannot find me some plans, then you need to make some, or I could come and make some for you, but that's not what I do. So it's going to take me longer, and it's not going to be great. Maybe you want to consider getting your site surveyed so that you actually have some quality floor plans for you. So really, floor plans, do they exist? If not, I need them before we can proceed. If we do have plans, great. What format are they in? And can I do anything with that format? And then we start going down the path of, oh yeah, great, I've got these .dwg files. I don't know what they are, but yeah, here you go, here's my floor plans. And then I look at this and I've now got a file with 1,000 layers. Every single piece of detail about that site is detailed. So I've got like the electrical conduit routes and the drainage pipe systems and where the individual sinks are going to be inside your building, and that's great. But then I need the skill set to be able to strip that down and pull the data that I need, because a quality floor plan is great, but too much detail is also a problem. But I mean, that's best case scenario when you get a, do I need to, is that it? Do I need to shut up and move on? Is that, that's
No,
fine.
you're
Okay,
good.
Then in
You're
that case,
good,
the very last, then my very last point was, yeah, so that's CAD files, but then even with rasterized image files, just like regular image files, some basic skills for manipulating those images is critical for us as well, because again, I can just strip out detail that I don't need.
Absolutely, absolutely. And like the tools range from Photoshop to PowerPoint for, editing rasterized image files. And I was ashamed one morning when I was going to a customer site and had to do some quick image editing. I actually found it faster to do in PowerPoint than in Photoshop, the basic things that I did. And I was like, I'm not a real engineer anymore. Not that I ever was, but anyway, Joel Crane, what's your favorite important aspect of Wi-Fi design?
Yeah, I think it's documenting hard requirements based on customer feedback. And before we depart from the floor plans thing, one way that I like to think of the floor plans thing is, you guys remember on The Princess Bride when they need to storm the castle and the guy with the key is like, no, I'm not letting you in. And then they bring in Andre the Giant. And he's like, oh, you mean this gate key, right? And bam, now we get the key to get into the castle. I kind of like to think of floor plans as like that. People have told me like, oh, we don't have any floor plans. I'm like, well, I'm sorry, I can't do a design for you. And they go, oh, you mean these floor plans? Everybody has floor plans. They've got them.
That's so true.
They just aren't willing to like send that one email to the guy that has them, or go, look in the closet where they're all rolled up or something like that. So they're there. So
100%. That same goes with the CAD files. Oh no, we never had CAD files. Well, it would be actually $2,000 less expensive if you did. Oh yeah, here we go.
And I just kind of want to get a show of hands from all of our panelists here. No, you see your hand. Put your hand back down. What is your favorite file format to get? Like what's your favorite format to get floor plans in? Is it a DWG CAD file? Ooh, no hands.
It might be.
Oh yeah, too. Yeah. Is it or is it a PNG file? Oh, am I the only one?
I was going to say PDF. I like PDF.
I was going to go PDF.
Presumably you mean a PDF with optional content groups. Full to the brim of optional content groups, right?
Guys, this is why we don't let Nick come on webinars.
I think
but I agree.
DWG, DXF, or SVG. SVG is outstanding as well.
Yeah. Cool. Well, let's go ahead and move on to the thing that I was supposed to talk about. Jussi, can I share the screen? Because I actually have.
You absolutely can.
Unlike everyone else, I actually have slides. I actually prepared for this by copying a slide.
Look at that, guys. That's why Joel is getting paid for this, and you guys ain't.
Okay. I really hope I have the correct screen this time. Oh, I do. Okay. Whew. All right. I'm learning how to use GoToMeeting. I'll have this figured out by the end of the day. Sorry, this is my first webinar. I've never done one of these before.
You'll get there, Joel. You'll get there.
Just to kind of finish up, I'm not going to go over all this again because I feel like Francois totally covered it, but I do think it's very important to ask these questions up front. And part of the reason why you want to ask these questions up front is also a way to protect yourself when it doesn't work. If you gather all these requirements ahead of time and you deploy a network that meets the requirements that the customer agreed on, then when the customer tries to use the network in a way that doesn't conform to the original requirements, like maybe you designed the network to support 200 clients, and a couple of years later, now they're pushing 500 clients on the network, and they come to you and say, hey man, we installed this network 2 years ago. How can this be failing already? And that's when you can point them to the documentation and say, hey, we originally agreed on 200 clients moving X amount of data. And so there's multiple reasons why you would want to iron this stuff out with your customer, with your end user, with whoever it is that's helping you set these requirements ahead of time. And so, but we won't spend any more time on that because I feel like Francois totally covered it. What I like to do is I like to take those and turn them into hard numbers. Now, this is certainly not a complete list of requirements. These are only what I would call RF requirements. But you want to figure out what kind of requirements do we want to achieve on our network. Like, for example, in all the areas where we have decided that we want coverage, maybe we want to see coverage from a primary access point, the loudest access point we can hear. We might say, well, we want -67 dBm of coverage or better. Secondary coverage says, how loud is the second loudest access point. This is a reliable way to ensure that you have more than one access point covering each area, which gives us a couple of big things. It gives us redundancy in case an AP goes down, and APs do go down for code upgrades and things like that. Even if only for a few seconds, they do go down. This also gives us roaming performance because it gives client devices a runway between access points to complete those roams. Maybe that would be around, I don't know, -75 dBm or better, maybe -67 dBm. These numbers, by the way, are just me making stuff up. You know, you will have to come up with these for your own network based on your requirements. You're going to want to decide what is the minimum signaling rate that we want to achieve on the network. Remember, something like this isn't throughput. If you want to try to figure out what throughput is on the side, yeah, you can try. It's going to be tricky. But this is the signaling rate. Signal to noise ratio is another one. How much signal do we want to be able to hear above the background noise? And finally, one of the most important ones that I think is overlooked all of the time, this one is just blatantly overlooked, is channel overlap. This one says how many access points will we allow to share a channel above a certain signal strength threshold. For example, we might say we don't want more than one access point above -85 dBm, because that's about the line where if we hear something above -85 dBm, that's when a device will back off and shut up and be quiet and wait for the other device to finish talking. Back to you, Jussi.
Thank you, Joel. Thank you, Joel. Very, very good stuff. I had my favorite as well. That goes back to, hold on, where am I? So let me share my screen. Can you see that?
Yes.
So one super important thing for RF or radio frequency performance is how you mount the access points. If you mount the access points behind the pipes, you know, right up there in the ceiling, if you hide them behind the bookshelf or you know, down low on the ground, stuff like that, the radios are super sensitive, and you know, the better like almost like line of sight the client devices have to the AP, the better usually the system will perform. So this is an example of a good mounting methodology. So you have a difficult place where you can't really put the AP up in the ceiling, you just lower it down sufficiently so that, you know, things work okay. Did I have another one from here? I did. And then you can even go a bit more exotic if you want to really, you know, just to make the point. This is you know, what is it, the spider AP or something like that. But as long as that AP has a good line of sight, or not necessarily line of sight, of course, because of walls and stuff like that, but don't hide your AP in the false ceiling or things like that. And as always, there's always, you know, examples of really, really bad Wi-Fi at badfi.com. For example, do not put your AP in the wiring closet, or do not use antennas that are not built for the purpose. And you know, don't use antennas in an orientation they shouldn't be in. Don't you know, put the plumber to do your AP mounting work, and especially do not prepare your APs to be put into the oven. Okay, so that's AP mounting, super important. All right, but that then takes us to our next step, which is the demos. So guys, I did ask you ahead of time, we did prepare for this, right? I did ask you to show some of your favorite Wi-Fi tools, if you don't mind. So first one on the line would actually be Chris. Chris, what do you have for like your favorite Wi-Fi design tool?
So I've actually got a little bit of an oddball here, is that I have got the AirCheck G2.
But that's a very common device, especially for IT people who need to maintain and troubleshoot Wi-Fi networks.
Yeah, absolutely. It's it is a common device to have, but when it comes to design, it's not often used except for a very specific use case. So I really like it for troubleshooting, and I really like it for troubleshooting that. Especially right now where you can ship the AirCheck somewhere, you can connect it to the wired port, and you can, just like I'm doing right here, that you can VNC into it and get all the data that from on-site from your desktop But I also like to use it for wall measurements. Is that if you look up in the top right now, that it's scanning through all the channels, and if you have your signal source for wall measurement set up on channel 36, it's actually going to take a while for it to loop around, scan all those channels, and get multiple data sets from channel 36. But if you go down to the settings, you go to 802.11 settings and then channels and bands, you can turn off 2.4, and you can only have it scan on channel 36. So now it's scanning 36, 36, 36, 36. You're getting a lot of different data points from that individual device.
Hey,
I'm gonna look here.
Chris, let me stop you right there. Just for those that don't know what a G2 is, any chance you could Google a picture of the G2? Because this is not actually something that you have running on your laptop, as one might think here.
It is not. Let me grab that.
Oh, Rowell
Rowell's
beat
got
you to it. That's good. So what Rowell is showing is the net. Is it these days? It's Net Ally, previously
Net
Net
Ally
Scout G2. So kind of the de facto one-touch, super simple to use, quick to start device.
Yeah, it's a really cool device that you can get a lot of data out of it. You can save the files off into CSVs and look at them later. They've got a cloud portal that you can have test results automatically update to. I like this device a lot. So right now I'm looking at just my home infrastructure that we're seeing the signal level at neg 51 on channel 36. I don't think anyone's up yet. It's over in the other room. So there's actually not a lot of variance between it, but a lot of times in a lot of infrastructures that you'll see it bouncing between neg 51, neg 53, neg 52. You want to get multiple data sets to be able to get an average of that value before you put an attenuating object in between in order to measure the wall loss of or the loss of that attenuating object.
Very cool. Very cool. Thank you, Chris. That's very good. Next up, Rowell Dionicio. What do you got for us in terms of your Wi-Fi design tool?
All right, so how do I take control here?
Chris has to
Allow
stop.
me, sir.
I
No,
believe
he
I've
doesn't.
stopped.
I'm okay. I'll just pass the ball to Rowell. There you
Hey,
go,
at
Rowell.
least you didn't share the wrong screen like I did, Chris.
All right, you guys see that?
Sure do.
Yes, sir.
Yes.
All right, so my favorite app is always the one that you always have with you, and that happens to always be my iPhone. And it happens to always be one of the worst performing devices or worst capable devices on a network, is everyone's always on their phone. And so if you, on an iOS device, if you download Airport Utility, you just got to go to settings and enable the Wi-Fi scanner. So at the top, you can tap on Wi-Fi scan. And now I can see all of the, if I hit scan, I can see all of the networks that my iPhone can hear. And so I can see the signal strength, the RSSI of each network. And you can compare this to something like an AirCheck G2 or to a Sidekick and be able to see what the difference is of signal. Because if you rely solely on, say, a Sidekick, an Ekahau Sidekick, you'll notice that the radios are so much more powerful, or they can hear signals way better than, say, an iPhone. And plus, people hold iPhones differently. So because it's so small, you can see that people, they're either using it on the side of their head, they're either in some weird position that their body's blocking most of that signal. So you can actually see that the signal, how often it changes if you just put your body or your head in front of it. And I know from presentations that people have done, you can get about like a 10 dB loss from your body. So I use this a lot, especially if I just happen to be doing a quick walkthrough and I don't have all my tools with me. I just take out my iPhone, look at Airport Utility, and start looking at different signals from here. And once you're done, you can actually export this and send it to yourself via email, or save it to your notes app.
Very
Yeah, and
cool.
one thing
Yeah.
one thing I really like about Airport Utility is that export functionality. So you can airdrop it as well to your MacBook, and then another tool, Wi-Fi Explorer, you can open up that Airport Utility file and get a graphic representation. That's just fantastic.
So that's my app, my favorite one to use. I use it all the time.
All right, thank you, Mr. Dionicio. Next, Mr. Verges.
Yes,
Francois,
it's me. So,
there, man. By the way, we lost your video.
I know, and for a good reason.
Our videos, everybody, please.
We all need to kill video, actually. Yeah, there we go.
So can you see my feed?
We can. And Chris, Nick, and Rowell, if you can shut down your video.
Thank you.
Mine's already done. There. Whoa, now I'm showing everything.
No, dude, you're there still.
Okay, so here the
Rowell.
yeah.
Rowell just wants to be seen, man.
I clicked on stop showing screen, but it's
I
still
think
showing.
it's because he's the presenter.
Can I be the presenter then?
No, Rowell's screen is different from your video. You need to go webcams and stop showing my webcam.
Okay. Hide all webcams. No,
we can see
my webcam. There you go.
There we go.
Yay!
Okay. Is that good?
Yeah, man. Good.
Okay, so the tool I wanted to talk about is the WLAN-PI, and especially the profiler application that we have on the WLAN-PI. The profiler application allows us to study the Wi-Fi client device, the client devices, and especially their Wi-Fi capabilities. And when it comes to design, there are two pieces of information that I usually look at: is the channels that the device supports, that the client device supports, and the maximum and the minimum transmit power that the client is capable of. And I can use the profile application to do that. So I'll show you how this works on a WLAN-PI. I have a NIC connected to it that will be used to start up a fake Wi-Fi network, and directly from the panel. And I'm going to zoom in here so you guys can see. How is that?
We see it loud and clear, man.
Excellent.
Okay, let me make it. Okay, perfect. And so here I'm just gonna turn it back on again, and I have a menu, and I can go down to something called app, right? And then next, and then they have something called profiler here, next, and I can just start it. So if I go down, start, boom, I can start it, and then if I exit here and I go back to status here, and I do next, here it's telling me that it's actually running, right? And no client has been detected.
What this does is it makes an AP out of your WLAN-PI where the client will associate to, and then the Pi will collect, is it the association response from the client device from where it will actually get all the profile information of the client that you can then use later, such as transmit power and supported channels of the client device.
Exactly. So it's actually the association request sent by the client device. And you're right, in this frame, in that specific frame, the client device will show off all of its Wi-Fi capabilities, and we can hijack that and then gather those information. So what I have to do after that is I take my supercritical Wi-Fi device. So here I have,
oh wow, you didn't save on the tablet, did you?
Yeah. So no, I didn't save it on the tablet. So I'm going to turn it around so you guys can see that. And then right now, if I go to my Wi-Fi setting, I should have something called WLAN-PI. Do you guys see it?
Yep, we see it. We see your Samsung tablet. We see all the information.
Okay, so here I have my WLAN-PI network, and if I try to connect, what I have to do is put a random password. So that's how I put a random password, and then I connect, and then here it's going to try to connect. It's not going to work, and we don't really care about that. All we need is the association request frame from the client, and here you'll see on my WLAN-PI, it will show you that it has detected one client device, right? And if I zoom in a little bit and I try to focus, you should see that here we have a Samsung device that got detected. So now what I can do is I can go back to my laptop. I actually have the WMPi here connected to my laptop via USB, and I can actually HTTP into the device and then see all the results. So I'm going to try to share my screen. You guys tell me if you see my screen.
We can see your
we can
screen.
see it.
Okay, awesome. So now I can just HTTP into the IP address of my WMPi, which is 192.168.42.1 by default. And here I have this profiler tab, and I can click on the clients. And here I can see, I think this is the one we care about here, and I can see the result as a text file. And here you can see that, you know, I have my max transmit power, my min transmit power. I can see which that AC is not supported. And then I can see all the channels supported, right? Here you can see that I don't have 120, 124, 128 in this case. And I can use that data to do my design. You know, maybe if I'm using this device and I'm in the US, I'm not going to use those channels because I know this device doesn't support it. And I'm going to be careful about my transmit powers as I design.
So transmit power, I wonder if that's out of the radio or EIRP or?
I think it's a transmit power out of the radio, I would say. Yeah.
Okay.
Before
the antenna.
Before the antenna. And here, as you can see, I get the results for the 5 gigahertz frequency band. If I want to get the result for the 2.4, what I can also do is tell me if I have time to SSH into the box, you see.
If you do it very quickly, Francois.
Okay. So let's see how fast I can be. So here, I'm going to stop it. I'm going to stop it from the screen here. I'm going to very quickly SSH into the box using the WLAN-Pi.
What I love about how the WLAN-Pi works like this is it shows up on your machine as a USB Ethernet adapter. So he has a network connection through the USB cable, which is pretty rad for being able to get into it with HTTP or SSH.
Yep, and it's super easy. It shows the IP address right there on the Pi display as well. People shy away from using the Pi because it's complex and Linux. It's really not. Plus, there's like some really good tutorials, like from Wi-Fi Nigel. I think he just posted like his 10 favorite things to do with this that are super easy, and he goes through all of those from the get-go in his videos. So Wi-Fi Nigel.
All right. So, am I doing something wrong here? Yeah, I was. So here I'm just starting it, and the -C is allowing me to set the channel. So I'm setting channel 1, so I should have it on 2.4. And then when I go back to my tablet and I'm going to run it again, try to connect again, but this time it should try to connect on 2.4. So I'm putting the random password right now. I connect, and then here we should see the report on 2.4, and you can see on 2.4 we have different transmit power values. So that's something that you can also study for your critical devices. I don't do that with every devices, but if I have some critical devices, let's say you're in an industrial environment and they have very specific devices, you can do that with just a WLAN-Pi.
Okay, cool. Thank you, Francois. Thank you so much. And next up, Joel Crane. I was going to say Nick Crane, but it is Joel Crane, isn't it?
Yeah. Or do we want to let Nick go first? Because I think his demo is probably more important than mine, and we're kind of low on time. What do you think?
Oh, yeah. So for the audience, we will go over. We apologize again, but we will go significantly over. Also, presenters, if you can stay, please do. If you got to go, we totally understand. So let's start with Nick. Sorry. And this time I mean Nicholas Turner.
Okay, all right. Actually, me this time. You guys can turn your videos back on now if you fancy. I'm going to share a little bit of my screen in a moment. My favorite, my chosen topic for my favorite tool for this one was going to be. Well, it's not going to be. It is the topic I've selected: databases, storing and collecting our data in a flexible, structured data format. And this can mean anything, really. But what I want is when whenever I'm faced with auditing data, it can be lots of different types of data. It's the AP height. I need to take a picture. I need to also record some notes about the AP's location. I need to write down, are there cabling routes available? Are there network points going to be here? Great. Okay, now I'm doing an installation. I need to quickly just write down which patch port is this going to, which switch port is that, which switch is this going to, and the list goes on and on and on and on of complexity. So what I want to use for that is a friendly to use database software at the very highest level. I think Excel is great for this because I can just throw data at Excel and I can then see it all on my screen at one time. That's okay, but really then to take that a little bit further, and now is when I will share my screen, maybe. No, I cannot. Could you share my screen for me, please?
Just a second, Turner. Let me make you the presenter.
No problems.
Your name is Nick Crane, right?
Nick Crane or Joel Turner. That's right. Yes.
Yeah, got it. You should have it now.
Cool. So what I'm just showing you here is FileMaker. FileMaker is very much like Access for Windows. And what this is a database software. So this is, you can think of this exactly the same as Excel, except I'm looking at each record, each row as a different page, and you get different types of views, right? If we were to look at this, the data inside this file, that's in details. Oh well. Oh, okay, never mind. But imagine if I exported this data out of FileMaker, then it would look like an Excel spreadsheet, right? It's this data. There's nothing fancy going on, right? It's just text data stored inside a database tool. But what I like about FileMaker is that I can change anything about this user interface completely. Like, what I actually want is there's another box for let's say like model, antenna, and mount and height were the ones that I was using all the time, right? So I just created a new field for those, and now I want to start stepping through my APs. Well, I'm just moving down a row inside my Excel document. And what I like about FileMaker, and it's not, I know that some database purists out there are gonna laugh at me for liking FileMaker, and that's fine. But what I do really like about FileMaker is that it already has views built into it for like your iPhone. So for example, I can look at this exact same data through my phone, and I'm now browsing the same, I'm actually browsing the same data as the version, as the database on my laptop, but I can look at this now in a format that's much easier for me to use on my phone. And then you discover during one project, I really wish I had a box that could do X. Great, make it. You just literally create a new field for it. And where do you want to put that on your user interface? I don't know, here. And there you go. Yeah, so FileMaker and Excel, check them out.
Nick's favorite Wi-Fi tools.
Check them out, bro. All
Great.
right.
So if the Ekahau folks are on the line, can we get this in Ekahau?
Yeah.
Nico's already promised me one more feature in Ekahau today because of this webinar. So yeah, I'll bet he would do that too. Thanks, Miko.
Oh, he will definitely do that. So speaking of Ekahau, Joel, you're the second to last. So you have any Ekahau stuff for us to show?
Yeah. Let's just very, very quickly look at some Ekahau stuff. You want to make me the presenter so I can?
I'm gonna keep hold of that. I'm going to stay the presenter and not share my screen. Oh, it's gone.
Sorry.
All right. But which screen was it? Was it screen 2? Was it main screen?
Just share both, Joel.
There we go. Yeah,
just share both.
Just share both. So I'm just going to very quickly expose you to what a virtual network design tool is and how you can use it to design the network and also validate the network meets the requirements. So one thing that I totally did not do ahead of time is actually define any requirements. So these are all those requirements I talked about earlier. Let's make our secondary signal strength. That's signal strength from our second loudest AP. Let's make it -67 dBm. Let's do 25 dB of signal to noise ratio, minimum data rate of 24 megabits per second, no more than one AP sharing a sharing the same channel above -85 dBm. So now we've set our requirements, and you can use a tool like this to go through and plan the wireless network. So for example, right now we're looking at signal strength in the 5 gigahertz band. Everywhere that you can see color is where we are meeting our requirements, and everywhere that's gray is where we are not meeting our requirements. So we could go through and place all of our access points to plan out this network. Like there's a kind of this spot over here is a little bit dead. So let's place an AP right there to kind of fill that gap in a little bit. Now, one thing that this tool is relying on, to Chris's point earlier, is that this tool is relying on good data in. Right now, we are making a model. This is a predictive model. It's only as good as the data that we put into it. So for example, like all the walls, I used a 3 dB drywall. So each wall attenuates signal by 3 dB. Well, if it turns out that these are like super walls that are like 5 or maybe 6 dB of attenuation, if we change all those walls to reflect that new value, all of a sudden we've got dead spots, we've got gaps in coverage all over the place. So it's really important to go on site and actually take some measurements and find out what does the actual environment look like, and use that data to inform your predictive model of what the network looks like. You can't just do this stuff remotely. You can't just plug in a bunch of values and go, oh yeah, that's what it's going to look like, because that's not what it's going to look like at all in the real world. So what I like to do is I like to design the network to simply achieve all of my requirements. Notice that right now we've got a bunch of areas. In fact, the whole thing is we're failing to meet requirements all over the network. And so, so like, for example, we need to figure out what's going on with our secondary signal strength. If we look at secondary signal strength, we actually don't really have it anywhere. So to fix that, we can go through and place some more access points to start filling in those gaps in secondary signal strength. So we'll go through and place a few more here. I'm not going to do a very good job of this just for the sake of time. We'll put one in right there, and there we go. So we've kind of got things filled in a little bit better. If we go back and check our requirements again, okay, we're doing pretty good on everything except for channel interference. We have really bad channel interference everywhere. Well, then we can run the channel planner to have Ekahau sort out what channels all of the APs need to go on. But remember earlier, let's say that we're designing this network for Francois's Galaxy tablet. Francois, what channels did your tablet not support off the top of your head? Do you remember? You could just make stuff up. Nobody remembers.
Yeah, 120, 124, 128.
So 120, 124, 128, it does not support those channels. So we can take those out of our design and hit create plan, and Ekahau will sort out which channels all of these APs should go on. Now, how does this match up with Mist though, where we use radio resource management and the Mist cloud figures this stuff out for you automatically? Well, what we can do with Ekahau is we can use it to make sure, is there enough frequency space for all of our access points to find their own channels? Is Mist RRM going to put this access point in the lobby on channel 52? No, it's not going to end up on the same channel, but we can at least use this to make sure that we have enough frequency space for things to work with. So once you're done with the design, then the next step is to of course install it, get everything deployed, turn it all on, let RRM sit for 24 hours or so to work out everything, and then you should go on site and do what is called a post-installation validation survey. So this is where I've gone through with an Ekahau Sidekick or Wi-Fi adapters, and we've gathered data from this whole network, and and so now we can see, are we meeting our requirements in the real world or not? So if we look at network issues, notice that everything is fine, except I've got all these areas that are yellow. Those are areas where I'm not meeting my secondary coverage requirement. And so we might have to do a little bit of remediation to try to fix that problem. And the reason we have this problem is because my predictive model was not accurate. I didn't put enough data into the predictive model. So that's a very quick look at how you can use a design and survey tool for stuff. And we're way over time, so I think with that, I'll turn it back over to Jussi.
Thank you. We've almost covered like half of what was on our agenda for the day, but we will continue. So stay on the line. We still have a ton of people on the line. So let's just go with it. So one of my favorite things I wanted to show in terms of a Wi-Fi tool is like, this is what I thought about last evening, is like, people often talk about design as like, requirements, planning, and then validation, and boom, it stops there. But what's pretty important, especially with these like self-configuring, self-driving, self-healing, whatever networks you call them, they kind of settle down over time. And once the users start adopting the network, that's when really, you start seeing, what exactly happens with the network. So that first week of actually using the network, to me, is the most important thing that people are overlooking. It's a very, what I'm saying is it's very overlooked how the network performs during the first week when the users join the network. Let me show you what I mean. I will steal the presenter ball from whoever had it, Mr. Crane. Can you see my main screen?
Yes.
Yeah.
Yes. And I just randomly took a Wi-Fi infrastructure dashboard. This happens to be a Wi-Fi vendor called Mist. Joel, have you heard of Mist?
No, you haven't.
Stuff up. You don't need to. It doesn't need to be accurate.
But anyway, this is actually my switching network and its performance. So let's look at wireless network. So I'm looking at my site, Nakatomi Plaza, for the last 7 days and how that's been. So kind of like what we saw there with Joel's criteria, we look at certain key characteristics of the Wi-Fi network, and when we let it run, for example, for a week after the deployment, this is where the rubber meets the road. How is it truly performing with actual end users out there? So this is nothing needed. This is just the Wi-Fi infrastructure measuring the user experience of the clients all the time, from all the clients for the last 7 days, from all the access points. So the entire network is here, all of the clients kind of summarized into one page. We can drill down to all of these specifics per client as well, but this is just looking at the metrics of the entire network first. So we can see, like, can the clients first of all successfully connect with the network? Joel, would you be happy with 91% success on successful connects?
Yeah, I think so, because every now and then, DHCP is gonna fall over for a half a second or something like that. It kind of depends on how many connections we're talking about.
But 9%, man. Let's say 10,000 clients. That's 900 clients, not successful.
Yeah, you're right. It does scale up, and Nakatomi Plaza is a pretty big building with lots of ventilation ducts and stuff. It's big.
And there's some pretty important clients there, like Hans and John and all of those guys. So point being, like, out of those 9% that failed, we can see that authorization was the problem every time, and then we can start drilling into, like, okay, what exactly was the problem, what were the problematic clients, all that fun stuff. Oh, sorry about that, I totally misclicked on it.
What did you do? Oh, your time span got screwed up.
Yeah, sorry about that. So anyway, so that there you can start drilling down, and same thing for, like, how long did it take for the clients to connect, and you can also set these thresholds, just like Joel was setting in the design Ekahau design tool. We can similarly set the thresholds in here as well, and see, hey, users are actually suffering from low coverage, mostly due to weak signal. So there's no asymmetry, like client hearing AP not hearing client. That's not the case here. It's just pure old-fashioned weak signal. What about the throughput? And you can see what is exactly failing on all of these things. So this is the first week. I think that's just often overlooked. But now, Joel, what do you think? Should we just do some roadmap items here that nobody has ever shown before, right? I'm sure we won't get fired for that.
Hopefully we won't get fired. Let's just do it and see what happens. What's the worst?
Let's just do so. So Joel was showing, and I mean, we only have a few hundred attendees on the line anymore. We're way over time, so I'm sure nobody will even know this. And those guys have probably dozed off already in the audience anyway. They're totally inactive. So Joel, have you actually seen the Ekahau Mist integration in action?
Like one time a few months ago, back when Ryan Adsma just first had it working. It was like it
just barely worked. UI.
No, I
have not UI.
No.
Okay, should we take a look at that? Absolutely.
Yeah.
So what I have here is a site of 2 floors, and then if we go to live view, I have no maps put in here. Of course, the system runs without maps and all that, and we could manually put in the maps here, right? And then, you know, drag and drop the APs on the map and all of that. That can totally be done. But if we wanted to, you know, be a bit faster with the process, kind of fast forward things a little bit, we can now also import floor plans into Mist. And this hasn't been released yet. I don't think anybody has talked about this publicly yet. So this is kind of cool. So what I'm gonna do is I'm gonna drag and drop my Nakatomi Plaza file in here. That's an Ekahau file. Let me actually show that to you. While I hit import here, I will show you the file that I'm importing into Mist. So that's a regular Ekahau file here, 2 floors, a vault, and the 32nd floor. It has, you know, plenty of APs. Most of them I have actually associated MAC addresses with the planned APs, except for one. So yeah, just a regular Ekahau planning file, multiple floors, you know, different amount of APs per floor, all of that. So let's see what the Mist says. Floor plans imported successfully. Can you guys see this?
Yes.
Okay, so perfect. Floor plans imported, 6 out of 6 APs on that map, 1 out of 1 on that map. So let's just click match APs. So here, if we had some, so it actually has automatically even matched these APs that we had on the Ekahau file directly with the APs that are on the Mist system. So you had to do absolutely nothing. We just drag and drop the Ekahau file, automatically associated the Ekahau planned or simulated APs with the Mist APs. And same thing with the other map here as well. I'm gonna click finish. Okay, we have 2 maps, and let's check it out. If we, for example, look at Vault, yeah, there are the APs. We can already see clients being associated to the APs, all of that stuff. So simple drag and drop from Ekahau to Mist, and all of this works straight out of the box. And
I couldn't help you see, but notice that all the clients in the vault were all clumped together. Is there like a hostage situation going on there or something?
yeah, they're next to the fountain there on, you know, yes, there was some guy shooting some machine guns, all this kind of stuff. So let's say if there's a scenario where, you know, one of the APs that we had in Ekahau didn't match with what we had in Mist. Let's say you know, there was a misconfiguration, you mistyped something in Ekahau, you can just drag and drop that AP in Mist to its appropriate place, and now it's all there. So all I'm saying is 0 Mist boxes installed. This was just the APs and the cloud. You didn't need any extra bells and whistles. You didn't need any extra configurations. Drag and drop the Ekahau file there, and there you go. So yeah, that's the Mist Ekahau integration. So supports simulated Ekahau files, so predictive files, brings in APs, floor plans, AP names, that kind of stuff, automatically associates the APs. What do you guys think?
It's awesome.
That's really nice. Saves a lot of time.
For some reason, I have worked with different integrations with Ekahau, and this is at the risk of being a bit biased, I think this is the smoothest one by a mile out there.
So does it also take into account the channels and transmit powers, or do you guys just rely on RRM to configure those settings?
I think like such a huge percentage of our clients use RRM that it today doesn't take in the transmit powers, and that's as far, if I recall correctly, but it's like almost no one seems to use static anymore.
Didn't Wes like pull the numbers to look and see what percentage of our customers were not using RRM and present that at WLPC? And I thought it was like some ridiculously low number. It was like 0.01% of our customers do not use RRM, something like that.
What about the AP AP node images? That would be nice to have them in Mist as well.
Yes. So Mist has actually AP nodes built in. For example, you can use the Mist mobile app to take pictures and then associate them with the APs. And then those are also brought in to the mist management system as well. So definitely it is there on the mist system side as well.
And then does that support, is that just predictives that you've associated a MAC address with, or does it support import of like passive survey results that you've surveyed and Ekahau has placed the APs?
That's a great question. So today it only imports predictive files, step number one. And like, this is where I've always had the question of like, why would you bring in passive survey files? Like, what's the use case scenario that's common where you would like to bring survey data in? And what would you do with that data? And
because you're just importing the maps with the locations of the APs, and then Mist is taking over, showing how many clients are on there per AP and that kind of thing, right? So that's why you only need the predictive.
Yeah, so I guess my guess for the passives is that no one collected the MAC address or serial number information and the APs went up. You could then just do a passive survey. You get the BSSID associated with the location, and then Mist can link those two together and say that's that AP, and it's going to be at this spot on the map.
That's very true, actually. That's very true. If there was like, because with passive survey, typically you don't have the absolute AP placements, right? You only have the guesstimates to work with that were collected by the survey tool. So if there was like, hey, that's close enough, I will just associate these together. Yeah, it would make sense in a validation survey scenario. I would agree. I would agree with that. It was for us, it was also like, what is the highest priority for the customers? What are the customers asking for the most? And actually, if you go to ideas.mist.com, and this is also, we always have competitors on the webinars as well. If you go to ideas.mist.com, you can see like what our customers are requesting and how they're being voted in there. And this was by far the highest voted feature, I think, for a long time, was the Ekahau integration. And yeah. So we are only 18 minutes over time, so I guess it's time for a Q&A at this point. We didn't go through the entire agenda, but first, before the Q&A, let's go through the last point of the agenda. What's the biggest what's the biggest thing people do wrong with Wi-Fi design? In 30 seconds, Nick Turner, you can start. Nick Turner, you can unmute.
Try and find the unmute button. Yeah. What's the thing that people usually often get wrong? I think the equating huge channel widths to huge smiles on Wi-Fi users' faces.
100%. So gigabits doesn't mean happiness after all. It's channel reuse, right?
Yeah. Did you want me to say more? I mean, or is that okay?
So is the summary like, if you're seeing Wi-Fi problems and you're using 80 or 160 megahertz channels, then you might want to reduce those, right?
Yeah, I think it's always, I mean, large channel widths are great if you can use them, if you're in an environment that can hack it, but it's always that battle, and I think universities are the customers that I've had that the most times with, because they have enough real estate and enough APs to have this problem, and they're like, oh yeah, well we need really large throughput on our from our Wi-Fi, so we're gonna rack them up to like 80 megahertz by channel. No, you can't. You literally, it's not that it is the bad idea. It's that you will cripple your wireless if you do this. Like, yeah, okay, it sucks that you've got to run 20 megahertz channels and the throughput number will be lower, but I guarantee you the experience for everybody using that wireless network is going to be better. So
absolutely, especially like we see here, especially the lower Wi-Fi channels are typically pretty crowded. So you probably want to use 20 megahertz even in this type of environment, right?
Yeah, I think use as large a channel as you can get away with until reuse is an issue, and then drop it down. And don't be ashamed to use 20 megahertz by channels. It's okay.
Don't be ashamed of your 20 megahertz. It's how you use it, right?
Exactly.
It's not the size of your channel, it's how you use it. Yeah. With that, Chris Reed, what's the biggest misconception in Wi-Fi or misunderstanding that people get wrong?
Yeah, so going back, I think we've covered it a couple of times, but going on site to collect the information is that a predictive isn't just at your desk, is that it has to happen on site. You have to measure those walls. You need a signal generator. You can use something like a WLAN Pi with a battery. You can just use your phone. It's not ideal because they're very power conscious, and that the actual strength can vary a little bit. Or like I've got this little D-Link DIR 510. They don't make them anymore, but it's a battery powered AP that's got its own little internal battery. So if my microphone is a wall, you have your signal generator probably about 2 meters away, and then you measure on this side of the wall, and then you measure on this side of the wall, and the difference in those values is going to be that wall loss. And if you measure those and you measure all of them, I can guarantee that the output of that design is going to be accurate, and you're going to get a really good understanding of what the signal strength is going to be everywhere.
Oh, Jussi, we can't hear you.
Sorry about that. Absolutely. I was just looking for, like, there is, like you said, for example, in the Mist app and Ekahau, there's the notes section, you know, there's the photos section, that kind of stuff. So your installers, while they're on site, definitely find that useful. I wonder what's been going on with this AP, for example.
Is that one having problems?
Probably. And there's the photo of it too. Anyway, what was I going to say? Rowell, what's your favorite misunderstanding of Wi-Fi?
I say putting all APs at 100% transmit power, thinking that stronger signal is always going to be good. But you got to remember that the clients often don't transmit at the same transmit power, as we saw with the profiler that Francois did. So while the client can hear the AP may not be able to hear the client.
100%. And here we can, for example, see if you're using our stuff, you can actually see when it's an asymmetry uplink or downlink problem. So when usually it's poor client cannot talk back to the AP, right? The AP can be set as loud as possible, but where's that setting on the client device that says, hey, use beyond maximal transmit power? And I think wearable and carryable devices are limited to like 25 milliwatts anyway, or something like that. So, or like, I don't know, 15 dBm, whatever it is, 14. Francois, what do you think? The biggest misunderstanding in Wi-Fi?
So I guess for me, it's not the biggest. It's one I've seen. It's a very big misconception. I haven't seen it often, but I've seen it when people use external omnidirectional antennas, and they have this misconception around the gain of the antenna. So they think that the higher the gain, the more area you will cover. So this is true only if you look at the horizontal plane. But if you look at the elevation plane, at the vertical plane, you know, the higher the gain, the flatter your coverage will be.
Yeah,
so people think
that the beam is.
Yeah, exactly. So people think that, you know, they'll use high gain antenna in high ceiling environment, thinking that, you know, I'll be covered because I have higher gain. But what they end up doing is, you know, spreading that signal right underneath the ceiling and sending less signal downwards onto the floor. So that's just you know, this misconception about gain on omnidirectional antennas, and also something related to omnidirectional antennas. Sometimes people overlook the fact of placing APs on the wall, thinking that omnidirectional means like a perfect circle of RF propagation.
Sure.
But yeah, but in some cases you have, you know, these, you know, down tilt omnidirectional antenna patterns. And so what you do when you put APs on the wall is that you'll have more interflowing bleeding, and you will end up seeing in the real world like clients connected to APs on different floors, you know, excessive roaming, and I've seen that causing issues in some cases. So that's just you know, omnidirectional antennas can be, you know, nice and easy to install, but sometimes if you study it a little bit more, you notice that, you know, the orientation do matter, and the height of the antenna do matter, you know, when you use when you use omnidirectional antennas.
Absolutely, and then that's when you want to hire like in any Wi-Fi environment really, but especially with like, you know, difficult environments like warehouses, manufacturing, things like that, you probably want to hire like an expert like Rowell or Francois or Nick Turner. You know, there's the experts out there that you know will do this for enormous amounts of dollars. Anyway, Joel Crane, do you have a big misunderstanding, except my misunderstanding of you know, time? We are 26 minutes
That
over
is,
time, and
yeah,
again,
yeah, I'll make it really quick.
Don't. Let's go over. Like last time I heard feedback, like just go over, but don't rush it as much as you did. So thank you, Ilpo Mäkinen, our sales director, for that candid feedback where you just put me down.
It's very unbiased feedback coming from Ilpo.
You are very, very welcome, Jussi.
Oh, Ilpo was still there. Oops,
He's
sorry,
there.
Ilpo.
Wow, Ilpo lives. I think the biggest misconception, like I talked about earlier, is co-channel interference. I don't think people think of access points as hubs like we should. Networks must be designed to ensure that each AP has its own frequency space that it can work in. If you don't do that, all your APs are on the same channel or having to share channels, then they have to take turns talking, just like old Ethernet hubs back when you were playing Doom on your old IPX, SPX network, all plug into the same hub.
100%, man, 100%. Preach. Let me just duplicate this map. So my favorite misconception is actually continuous site surveys and versus stop and go. So stop and go site surveys, obviously, and by the way, now I'm using my Wi-Fi adapter. So let's see if this.
You're okay so far.
Okay, good. So continuous site surveys and stop and go. So if you do stop and go site surveys, obviously you just go somewhere, you click on the map, and then you wait for the you know, this to go to the end. Then you go to the next location, you click on the map. This is super easy surveying, right? You go to the next location, you click on the map. And by the way, I really like the graphics improvements in Ekahau that Jarno Kinnunen, the UX guy, has recently done to the tool. These are just like, the tool looks so good these days. So this is how stop and go survey works. You just wait still when you survey. Okay, good. But now with the continuous survey, people always make the mistake of like, yeah, let me start walking, and I'll just continue walking. Then I stop and talk to Joel, and yeah, for a good while, I see him. He says, hey, you probably should work, and then I continue and I walk here and I click here. That's the mistake people do. So while I was in here talking to Joel, I clicked when I arrived there, but then I was standing still for, you know, a decent amount of time, and then I continued walking. Did I click there again when I continued walking? I did not. So this is what, like, I would say 90+% of site surveyors get wrong. When you do continuous survey and you stop somewhere for a while, even for a few seconds, you click when you arrive there to that location, and you click when you leave that location, because it's continually taking Wi-Fi samples all the time. So you need to, if you stop anywhere, click when you arrive, click when you leave as well. But if you immediately continue when you take turns, then you only click once, obviously, because you don't, in a sense, arrive and leave at different times. You continue straight off the bat. It is easiest maybe to do the continuous survey so that you try to keep moving all the time. And when you're stopped, either stop the survey or do remember to click on the location again when you leave. But since Ekahau doesn't really care how many surveys you do, you can, anytime you get stopped, just stop the survey. Anyway, that's my, what do you guys think?
Yeah, so from the ECSE class, click when you start, click when you stop, click when you change speed, click when you change direction.
Yes, sir. Yes, sir.
Chris, you were a good student.
That's right. Francois was my ECSE instructor, and I do have to say the ECSE class is fantastic. So if you're using Ekahau, or even if you're not, it's a great sort of intro to Wi-Fi. And then you start looking at the product, I don't know, 2-3 days into the class. It's a great intro.
It's a
Chris,
fantastic
you only
class.
say you only know that the rules because of my 200-second thing earlier.
Yeah, I don't need to take that anymore.
Yeah. No ECSE required.
That's the ECSE class he was referring to, obviously.
Jussi, should we
ECSE,
take a couple of questions and wrap this up?
We should. Hey, can we throw Tommy Järventi under the bus? I wonder if he's here. Tommy, do we have any questions? Oh, he's taken off. Even our own guys have taken off.
Nice.
Or has he? Tommy?
Yeah,
No, he's there. He's there.
He's there. Yeah, I have
Tommy,
a couple questions
Järventi.
flagged here.
Okay.
Tommy, bus is coming. Hey, Jussi.
Hey,
What do you
any
have on
questions that you've seen on the chat board, or mostly just doing emails?
No. There are a few questions actually, but I was saving those for you guys because they are quite specific to what we have been talking about. But so there was, for instance, from Germund, there's a question about the AP digit limit that you show the import of the data into Mist Cloud. So is there like a 12-digit limit for the AP name? Do you have any idea on that?
That's a good question, and the answer is I don't know, German. But shoot me a direct message, and I will respond with an answer. I will make the longest AP name anyone has ever seen and import that successfully into Mist.
I think the AP name, limitation is related to the information element. So I don't think it applies here because we're talking about a predictive design. So I don't know.
Yep. Or maybe that was the question too about the information element. But German, send me drop me a DM or an email, jussi@juniper.net and or mikko@ekahau.com, and we'll get the answer for you.
Just while we're talking about AP name limits, then the question is, what is the limit for Mist to broadcast, or even broadcasting an AP name? So not the same question, but just related.
I mean,
that's a really
what's the limit?
Question.
The limit's like 16 characters anyway, right? Or there is a limit.
No. There's no absolute limit. It can be 64 characters, 128 characters, 256 characters, totally up to the vendor what you decide to use.
Wow.
Or is it though? How much space is there in the information element?
It's vendor proprietary information elements.
In that case, we support 256 characters, maybe 512 characters. We support twice as many characters as other vendors.
Yeah.
Do you though?
So
please have someone from Mist reach out to me so I can update my table on my blog, because I don't think my
64.
Nick, have you tried it? You can try it yourself if you have a Mist AP. I know you have a Mist hook.
Yeah.
Has one.
I could try it myself. You're right.
Nick, I've just tested it, and 64 is the limit that the UI is letting you configure for the AP name. So now I'll try it and tell you what I see in the information element.
Nice. That's what I'm talking about. Live answers to difficult questions.
Hey, we have a question here from Mark that I think is a good one. His question
not that
is,
guy again.
Yeah, I know. Yeah, he always shows up on these webinars and asks these questions. Mark asks,
hey, Mark.
Assume we can upload the Ekahau design via API versus drag and drop. Can you do it via API?
Yeah, you can. Everything you can do via API. I think the API has been there for a while, but then again, it's also been molding. So the answer is yes, both can be done. And I know Mark uses a lot of automation, all that. So if I lied, then I'll buy you a beer. Okay.
One more question that's gone unanswered here, I think, is a pretty good one. I actually don't really know. I don't have a good answer for this one, so hopefully you guys can help. How do you decide which signal strength to use for secondary coverage?
What do you mean by that?
Like, how do you, when you're setting your network requirements, what criteria helps you decide what your secondary coverage should be? Should it be -67 dBm? Should it be -70, -75? how do you decide what your secondary coverage should be?
And
That's a
there's
tough
two
one.
schools here, right? Some say it's, for example, NEG 65 and NEG 65, both primary and secondary. Then some say it's NEG 65 and NEG 72, or even NEG 75 for the secondary. What's your guys' thinking?
Some of it depends too on how the client, the algorithm, which we don't know on the client, starts looking for a new AP. So you could have like a negative 67 secondary signal, but that doesn't mean that the AP is going to start joining to that signal if like you start roaming, for example. So I guess the question is, could it be about roaming? Could it be about if an AP goes down? There's a lot of different things to consider, but the number itself I have found to be difficult to figure out.
Yeah, so if the roaming threshold isn't until neg 70, having neg 67 or neg 65 secondary coverage doesn't really help you all that much, at least when it comes to roaming. It's got a little bit of a ramp up for it to start to scan, but not a lot. But if you're looking at secondary coverage for availability, if one goes down, then what is your tolerance for that? Are you going to almost double the number of APs? Because you need the same requirements for primary as secondary, or is just a little overlap there, and maybe RRM or ARM or whatever you're using can tweak up the power a little bit in those spaces.
And it's a budgetary thing as well. Like, do you have some customers have a strict requirement that you need 2 APs at Mac or this certain signal strength, for example, and then the budget might restrict you to a lower secondary in some cases as well. So I guess there's not a clear answer to this, but I haven't seen something like NEG 65, NEG 72 combination, like NEG 65 primary, NEG 72 secondary. I've rarely seen it fail in any circumstance.
And sometimes if you look at a very specific application like voice over IP, vendors would have documentation that would give you the information. You have to look for, usually it's a deployment guide or architecture document from different, VoIP phone vendors, and you can find those information for some of them. So sometimes you can have that if you look at those documents. I just usually open the document, do a search on DBM, and see what I get. And I have the answer. I have the answer to Nick's question if you want, Jussi.
Yes, sir.
You probably lost me for a while because obviously I'm connected to my Mist AP and I'm changing stuff on me. But so
we never lost you for a microsecond. Mist is good. AI, ML. Mist is good. AI,
exactly. So the answer is on the UI you can configure the name up to 64 characters, and in the IE you have up to 32 characters. So you can
64 and 32. Thank you, Francois. That's some pretty great detective work right there.
Oh, one more question. Is it enabled by default, AP name broadcast, or do you have to?
No,
it's not. Okay.
But you can do it. They have. I think in the UI you have a checkbox, or in the API you have a host name underscore IE that you can set to true if you want to enable it.
Yeah, there's at least the API call. Yeah.
I will update my table of AP name broadcasters. Thank you.
Thank you, Mr. Turner. Much appreciated. Okay, one last question.
I think that's it. I think we got it. I mean, there's been lots of questions and things. I've kind of answered them all one at a time, mostly just lots of banter and things like that in the questions. And so, yeah,
Here's one. I don't know whether this is more of a statement or a question, but it's same SSID on 2.4 and 5 gigahertz. So what are your thoughts on the same SSID on both the 2.4 and the 5 gigahertz radio versus separating those SSIDs?
I can give an opinion on that. I've done the kind of, design-based band steering method where I crank transmit power in 5 gigahertz and bring the transmit power in 2.4 way down and run the same SSID. I find that about 75% of my 5 gigahertz capable clients end up at 5 gigahertz. So it kind of works. It depends. But other environments. So if you absolutely need things to stay in 5 gigahertz, definitely separate SSIDs.
Francois?
Yeah, I have my thoughts on it. Lately, I've been doing it separately. So one is SSID for 5 gigahertz, one is SSID for 2.4. I really like it because you're not you're forcing the clients to connect on 5 gigahertz. If the clients initially connect on 5 gigahertz, they're gonna stay on 5 gigahertz the whole time, and you can maintain the Wi-Fi performance that you want easier on 5 gigahertz. It would be easier for everyone if the clients will take the good decision and we could just have one SSID and then just rely on the client to just stay on 5 gigahertz the whole time. But I don't think we're there yet, but we might, with the new enhancement in Wi-Fi, we might get there one day. One problem I have seen in the field of using different SSIDs is the fact that some devices only support 2.4. And I've seen that with the Apple Watch. So Apple Watch will retrieve its SSID configuration from your iPhone. So if your iPhone is connected to a 5 gig only SSID, then the Apple Watch will not be able to connect to the Wi-Fi, and everything will go through Bluetooth. And I think there's some limitation. I don't have an Apple Watch myself, but I think there's some limitation if you're only using Bluetooth for the Apple Watch. So that's the sort of things you could see with a lot of IoT devices, sort of limitations if you use single band SSIDs. But if you just care about the Wi-Fi performance and you want your critical devices to work properly within a consistent way, I really like the idea of separating the SSID or do a single band. I call it single band SSID.
Yeah. What about Rowell? What do you think on this?
I like to use a single SSID, but I'm in the same boat with everyone else. It's based on the requirements, but most of my installations is same SSID on 2.4 and 5. Generally, I do have to support a lot of 2.4 capable clients, so I design for 5 gigahertz, and then my transmit power for 2.4 is generally lower, but I will go back and adjust if there is like a large amount of 2.4 only clients having issues, for example. And so I will, if I know that there are 2.4 only clients, then I can still design to where the signal is not too low for those devices, right? So as long as you've got like a good mix, most clients are pretty good now at picking 5 gigahertz. So it's always just going back, right? So you design, you configure, and then you got to optimize. So you're always going to have to circle back somehow because things are always going to change.
Exactly. Chris Reed, what do you think?
So when I can, I prefer to split them to have the 5 gigahertz and the 2.4 gigahertz SSIDs be separate. Really to minimize that change of experience is that you've done a design and hopefully it's pretty good on 2.4 and it's great on 5 gigahertz, but 2.4 for the most part will always be worse than 5 gigahertz. So if you've got a client that's getting video delivery and it's your client is roaming between 2.4 and 5 and it's a 1080p video at 2.4 and a 4K at 5 gigahertz, that can be a significant change of experience for the client. So not necessarily that they're unhappy with the 2.4, but that the video is just flipping back and forth between the two of them. So it's a change of experience. So a consistent good experience is going to be better than a great experience followed by a poor one, followed by a great one, followed by a poor one.
And I've done what Joel did and trying to design it with a single SSID and try to adjust the RF as much as I could, and I had similar results. I think I had 80% of the dual band clients connecting on 5 gigahertz, but I still had like 20% of those client devices that could connect on 5 gigahertz that were stuck on 2.4.
And it also makes troubleshooting.
Sorry, you see, I just want to say it's not to say that 2.4 gigahertz is terrible. You have to look at it and see if there are issues on 2.4. So if the device is using 2.4 and it's working fine, it's not a problem. So it's just more
you just
available
have the extra capacity. Yeah, exactly. Yeah, extra capacity. Totally agree. But to me, it's like if we can, put all the critical stuff on 5, it just makes troubleshooting a bit easier. I can eliminate that one variable, and that already like from my first first course of troubleshooting steers me to a certain direction. Nick Turner, did you already answer this question?
No, my comments there, if I can separate them, yes, but if that's going to confuse, if it's going to add a burden to sort of training the people on site on how to use their wireless network, then no, then it's not achieving the goal. But I separate my own SSIDs here at my home because I want to know which band I'm on and control which devices are allowed to join, using which frequency band.
Very good. Hey, with that, we are only like 80% or like at 180% on time. So presenters, thank you so much, and sorry for going so badly over. I think we promised this to be a 1-hour webinar, but it ended up being almost 2. But I think it's been really good still. We got most of the stuff covered that we wanted to, and tons of good information. Thank you so much for the demos, especially like all the preparation, all the hard work. Special thanks to Francois for doing the live analysis of the AP name. Much appreciated. We didn't have time to play my game of what, where, and when, but we can save it for later. How about doing like episode 2 of something around good Wi-Fi later on? You guys up for that?
Sure, no problem.
Yeah.
Always.
Like, yeah, that was like an awkward 3-second silence followed by sure. Which I will take as a yes. Thank you so much, guys. Thank you, audience. We still have a 3-figure amount of audience members. So thank you so much for staying on. Let us know how it went. So reach out to us on Twitter, LinkedIn, and send us honest feedback. What could have been done better? What worked? What didn't? We're not just looking for the roses. We're looking for like how to improve these moving forward as well. So thank you, audience. Thank you, presenters. Much appreciated. Thank you, Ilpo, Tommy, and Tommy as well. Thank you, Arrow, for putting everything together, Tommy and Petri.
Thank you for the hoodie, Tommy. This thing is awesome.
Yeah.
This is a great hoodie.
You.
It has a Mist logo on it. Super cool.
Yeah,
Thank you.
it is. Oh, wait.
You're not wearing yours. Thanks, everyone. We'll see you in the next Mist webinar. Bye now.
Thank you so much.
Bye-bye.